Let's try to make a little equation here, or write a little program that adds two numbers together. So let's write out int value1 is equal to, let's do 3. Let's do int value2 is equal to 7. And let's do int total is equal to value1 plus value2. Now let's print this out to the screen. So we're going to do the quotes here. We're going to write total. And now let's do %d and add in total here. Now if we run this with Control F5, we see that total is 10. So why don't we format it in this structure? We'll do 3 plus 7 equals 10. Let's write it out like this so the code can understand what it's doing. So just to make sure this doesn't cause any errors, let's write a double quotes, and this writes a comment. We can write ourselves a little note here, and the compiler won't see it when it tries to run. If we do Control F5 again, we see that it runs without breaking. But if you run it like this, it's going to get a syntax error. It doesn't work nicely. Let's comment it back out. Now let's update this. So let's write, so we have a number here. We're going to have to put %d. So let's do %d, which we have right here. Space, plus sign, another space, another number, %d, another space, an equal sign, one more space, and then 10. Let's do %d. So some of you may be tempted to write it out like this instead, where you're going to write 7 plus 10 is equal to total. So this is true for this current moment, but the second you change any one of these values, you're going to have to completely update what this says every single time. And if you have this in multiple places, it's likely you'll miss it, and your program won't be accurate to the data inside of each variable. So let's try to avoid doing this, writing the actual numbers in when we have them in variables, because the variables can always change. Let's delete those, update this. So we need 1, 2, 3 different integers to store for our 3 %d's here. So for the first number here, we're going to want to put 3. Let's return this back to what we had before, 3 plus 7. So let's put value 1 in for the first parameter. Now we need another parameter for the second %d. Let's do comma, value 2. And then we're going to need one more value for the last %d. So we'll do another comma, and we're going to want to put in total here. Total is the total of value 1 plus value 2. Now let's save it, and let's press Control F5, and we'll see that it's going to write it as 3 plus 7 equals 10. 3 plus 7 equals 10. So what's good about this is if I change these numbers to 4 and 6, or let's do Control F5, 4 plus 6 equals 10. Let's do now let's do 20 plus 66. Save it, Control F5. 20 plus 66 equals 86. Here you can see that it's good to use modular code like this, where if something changes, it changes everywhere and it's compatible. So remember, if we did something like this, for example, two numbers equal 10, if you were to run it, Control F5, for the end user seeing this on their screen, they're going to say, this makes no sense. 20 plus 66 does not equal 10. It equals 86. That's why it's good to always keep %d here, to always have it as modular as possible. And if you have numbers in your code, store them in a variable and then place them in like this through %d or %f if it's a floating point number.